chemistry? Oh, look at that. Aren't those beautiful flowers?
Yeah.
Let me just do a little cleanup here. I had all kinds of static items in my classroom that the students could work on, and this was one of the things I might have had, where they would have flowers and they could have a spray bottle and oh, what's happened? It changed color. So what you got is an artistic aspect, but for the chemistry aspect, what else do you have here? They're not real flowers. Flowers, yes, okay, but what do you have here? I have Kleenex flowers that I'm just quickly going to go over. I can show you later if you want, but you accordion pleat, cut on the edge, and then use a pipe cleaner and then separate it to make the flowers. And then how did I treat these flowers before I sprayed them? I didn't put them in. They'd be pretty wet and dry. What I did is I used another bottle of phenolphthalein. So what happened to the flower that had phenolphthalein on it when I sprayed a base on it? What color did that change?
Light pink. Hot pink.
Pink. So how many of these 5 flowers did I put phenolphthalein on? No. 3. And this one was colored. This is universal indicator. And then, oh, what happened to this one? I didn't treat it. Okay, so you're getting into think. Now, if I let this go long enough, what's happening to this one already? The color's disappearing. And if I let this go long enough, you'd see this return back to white. And so I could do the whole thing again. So there you can talk about, well, how in the world is that changing back to a colorless situation? Or the original white of the tissue. And it's going to be interacting with the carbon dioxide in the air. The carbon dioxide is going to be reacting with the water, and so you can go through that whole routine. If you have, the desire to do this but don't want to make it, you can just buy flowers from Michael's or something like that and use those. So most of these effects are mine. I'd say about 90% are mine, and some of them